So actually introductory session, we all should aware of what is data and why the data engineers are required in the company and all. Just I'm giving this thing in brief manner so that you should also have the same thing in your mind as well. Okay. So what is data? Data is specifically a collection of information. Okay. It should be describing the quantity, quality, any kind of facts, statistics, values as well. So everything we are working should be data. And why data engineers are required actually? The purpose of data engineer. So data engineers, okay, just let me go to the next slide. So you can see there is, what are the different enterprises the data engineers are working currently? There are banking sectors, commercial sectors, insurance company, medical, pharmaceutical, those kind of stuffs are there, specifically heavily used over there. But there is lots of other things too. So what data engineers do, so in each of the system of this kind of system, you can see in the banking systems, each of the systems, when a customer goes to banks, their records are being stored in some databases. Records means the customer's ID, the customer's banking account, the customer's, their every transaction, lending, they're just borrowing something, they're pushing some money over there in their account. So everything they're got tracked in particular databases. Okay. So that particular data is being used. It must be fruitful by the customer, that will be no issue. But it should be also used to analyze the data by the banking owner or the authority to improve their business. Okay. So that is why data engineer will be playing the role. They will be helping the banking owner to take decisions. They will be flowing the data. They will be try to flow the data from the source system. Source means source transactional system. So suppose in the railway reservation system, the particular person who are booking our ticket, there is some mainframe stuffs. In the computer, if you can see the computer, there are totally black screen. They're entering our data. I'm going to this station to this station, another station. They're entering the data. How much ticket it will be costing? What is the time? Um, I mean, uh, I'm just have booking the ticket and all kind of information they're inserting in the mainframe, and the data is getting stored in some operational database. But that should be totally raw data. So the data engineer, they will be taking the raw data, they will be doing lots of transformation, cleansing operation, and they will store the data in data warehouse. Okay. And on top of data warehouse, some business logic should be implemented and all. They will be prepared the data in graphical charts, graphical format. They may be charts, various graphs should be there. And by checking those charts and graphs, the business owner, they can take decision how to improve their business, how they can find some hidden trends of data. And if you just quite aware of the probability and statistics stuffs, you can quite aware of the regression part, forecasting of the business. So that is also helpful. So especially who are doing MBA to be a business analyst, you can quite aware what is regression. Forecasting of the stuffs. So they can easily, correlate the things. Okay, and they can take the hidden pattern from this, and they can also help the particular customers to increase their business growth and all. So it's not only for banking, commercial. All the aspects. The same kind of data engineers have been. They are working for the same purpose. They try to represent the data with proper manner in front of the end user, so the end user can take easy decision, and they will be. The same business strategy will be reflected in the very next days. Okay. So that is the purpose of data engineer. They are just taking data from the source system, whatever they are collecting from the transactional area. and they're cleansing it. They're flowing the data from one system to another system and storing it to a single data warehouse. Okay. So that is the main concept of data engineer. So when you will be also onboarded in a particular project, maybe you will be working any of this industry, maybe banking industry, insurance industry, you are working in any of the thing, then there's you can also get each of the industry there might be have some functional knowledge. Just like for insurance, if you are working in an insurance, then you just have to check the insurance quote, insurance submission, the quote proposal, the particular insurance booking. When the insurance is been booked, a policy will be generated against that insurance quote. So this kind of stuff, the functional area is different for each of the industry, but the overall concept for technical stuffs, it's totally same. Okay, similar kind of stuffs. If you are working in pharmaceutical or medical company, you can see there are lots of information related to medical stuffs. It's not only just like the medical instruments, even the medical MR, medical representatives, how they are convincing the doctors, and which medical representative is having some more capability to what they are doing to particular, I mean, selling their product or to advertise their product in front of doctors or any other hospitals and all. So this kind of stuffs, there, I mean, focusing on that stuffs because everyone, each of the sector they are trying to grow their business, but it will be totally depending on how they wants to grow their business, checking their data. Okay, they're also checking their competitors' data as well. Okay, they're checking in which field their competitors are in front of, they're ahead or they're, why they're lagging behind as well. So this kind of hidden pattern, they want to get it from the data so that they can solve it easily. If there is any stuck point or any doubt, whatever I'm telling, please try to stop me and ask me questions. Okay. Okay. Moving to the next slide. Okay. So data should be having two kinds. One is called relational database. Another one is called non-relational database. So what a relational database? Below, there are two pictorial diagram. You can definitely, correlate what is the difference between relational database and non-relational database. The first one, it is called relational database. Okay. So the relational database always, the data should be formatted as row column based. First of all, there should be columnar structure and the column should be having one name. The first column is name and the second column is email. So for relational database, we need to create this kind of tabular structure. When the tabular structure is ready, we can insert the record one by one. Okay. So this is the concept of relational database. I'll be giving some more insights how relational database works and all in the next slides. But just to have in your mind, relational database should be having table based structure and the non-relational database should be looking like this. It should be having key value pair. Okay, it is not maintaining any structure. So, for a relational database, we need to create the columns first, then we need to insert it. But suppose I need to introduce a new column, suppose date of birth of the particular employee. Okay, then we need to update the table structure first. Then we need to insert the thing. But over here, suppose I need to insert date of birth for particular employee. Just we need to update. After this, we just need to update another key value pair. Which particular employee is having the date of birth? Just insert that key value at the next, very next. So this is the concept of non-relational database, and this is the concept of relational database. Okay. So the relational database, it's also called relational database management system, RDBMS. It stores information in tables. These tables have shared information between them. So in a database, there might be multiple tables. Okay. So the relational database can set up relationship between each of the tables. That is why it's relational database. So how they can set relationship? So, okay, let me go to the next topic first, then I'll be coming again over here. So this is an example. Over here we have customer table. This is customer table. In the customer table, we can see what are the different columns: customer ID, customer date of birth, order ID, address ID. Okay. And there is another table called order. In order table, we are having order ID, product ID, date. And there is another table called address. It's having address ID, line 1, means address line 1, pin code. There is product table as well, product ID, price ratings. Now you can see the customer table and order table is having a common column name that is called order ID. Okay. So by this common column name, we can set relationship between these two tables. Why we are setting relationship? Yeah. If there is any noise from my side, I mean, actually birds are singing over here. Please, if there is any difficulty, please tell me. And I found some noise from your side too. Yeah, now it's fine. I think it's from Harish. Okay. So the customer and order table, the common column name is order ID. And we can set relationship between these two table by this common column. So if we want to fetch for the particular customer ID, purchase which product at which date. So based on the common column order ID, we can definitely identify the particular customer bought which particular product in which date. Okay, by setting a relationship between these two tables. Similarly, in this table for the customers, we do not have the PIN code for this address ID. Okay, I have the access to this customer table. Now I want to check the address of the customer ID. Address is there, address ID is there, but the PIN code and detail address is not there. So I can definitely set a relationship between these two tables having address ID as a common column. Okay, I can take the data after setting the relationship between these two tables with this common column. I can get the PIN code information for this customer. The similar kind of stuffs, even I just want to check which product that customer bought for a particular date. I can just have a relationship on top of order ID. Then between these two table, order and product table, we can have a relationship between product ID and product ID over here. So setting up these two relationship between these two table and these two table, all the product related information should be coming over here first, then all those information will be coming to here too. Okay, by having those relationship in RDBMS systems, we can set this kind of, I mean, common column setup to get information from one table to another table. That is the concept of relational database. And two more things I just want to mention. A table uses columns to define the information being stored and rows for the actual data that I mentioned earlier. Columns of the table, it will be defining what are the information will be stored in that particular table. And each of the rows will be showing the data of that table. Now the next point is very much helpful. Each table will have a column that must have a unique value. It's known as primary key. Just like for this table. For customer table, customer ID is a primary key because in customer table we should be storing all the customer related information, and in that table we need to maintain a row identifier that should be unique in nature for each of the row. Okay, suppose I'm working in a company, I'm an employee over there. So the company will be recognizing myself, or they are entering my data into their database. Maybe there are employee table, and they're also giving a employee ID to myself, and that employee ID should be unique in nature. So in employee table, employee ID should be unique in nature. So that particular, this kind of rows or this kind of columns, those are called the primary key of that table. So for customer table, customer ID is the primary key for that table. But you can see order ID can be primary. I mean, it should not be primary actually. Address ID. So suppose customer ID 123 is having the address ID XYZ. The address ID cannot be primary key for that particular table because two customer can reside in the same address location, maybe same city. Okay. So that cannot be unique in nature. But if you come to that particular table, address table, address table only store the address related information. So it should be having some address ID XYZ. It represents this particular area and this particular pin code. Okay. For address table, address ID is the primary key. For customer table, customer ID is the primary key. Now, the address ID in customer table, it is called the foreign key. Okay. So in each of the table, there must be having some primary key information. They're not, I mean, it's not mandatory to have a primary key, but to set relationship between table, we should be having a primary key and foreign key concept. Okay. There may be some isolated table. I'm not studying any primary key related information there too. I'll be coming to this topic tomorrow. What is primary key? What is foreign key? What is composite key? It will with some detail manner and all. But today I'm just going to give some concept. Primary key should be unique for that particular table. So over here, customer table, customer ID is the primary key. In address table, address ID is the primary key. In order table, order ID is the primary key. In product table, product ID is the primary key. And the same key, when it's been used in other table, it's working as a foreign key. Suppose in order table, order ID should be primary key. Order ID should be unique in nature. But a product ID for this table is not primary key. You can see multiple orders, order 1, 2, 3, 3, 4, 5 is having, they can have same product because they can purchase the same product in different orders. Okay. But in product table, it will be maintaining the product related information. Product ID 1, 2, 3. It's a soap, suppose. Okay. So it's a different, I mean, maybe it's a pen or this kind of thing. So that is why product ID is working as a foreign key in order table and product ID is working as a primary key in product table. So while setting up relationship, the foreign key, I mean, we need to decide what is primary key and foreign key. Based on those two key, we can set relationship between these two tables. Similar kind of stuffs will be happening for each and every table. So I'm just repeating once more time. The table should be having one primary key and the same primary key should be working as a foreign key in another table. So we should have to set relationship between foreign key and primary key. Suppose order ID is the foreign key over here, order ID is the primary key over here. So you can set up relationship based on order ID between these two tables. This concept is there for all the tables. Okay. So that is the primary key and foreign key concept. So I'm mentioning the second point, I mean last point. The same steps. When one table's primary key is used in another table, this column is in the second table is known as foreign key. Okay. Primary key and foreign key concept, if it's clear to you, if it is not clear to you, please tell me. Any doubt or anything? There is nothing to hesitate actually, specifically who is, I mean, definitely whoever is completed your computers, I mean, masters in top of computers, there will be no issue. This is very basics to you. But whoever is trying to learn it for the first time, what is primary key, foreign key, please, if there is any stuck point or anything, you can definitely ask me. Okay, hope there is nothing. You're able to understand this. Okay, now I'm just going ahead with the relational database. So, starting from tomorrow or the day after tomorrow onwards, we'll be learning SQL, structured query language. So, what is this thing? This is a particular programming language, we can also say. Not exactly programming language, it's query language. So, but there we can traverse the relational database. So, structured query language, it's been used for relational database to query in the database to get, based on our desired requirement, we'll be doing query. We'll be learning the language over there to traverse the data on top of database. That is called SQL, structured query language. It can be called SQL, SQL, okay, anything. The full form is structured query language. It's a query. This kind of syntax we need to put over there. So suppose this is a table product. Okay, so select different column name from the table, and this is the filter. Which particular product I want to see from the database? We just need to put in this manner. Okay, in SQL chapters we will be just going ahead with more deeper way. Just giving you the concept for the SQL. Okay, now I also mentioned there is no relational database. So while fetching the no relational database, SQL will not be working there. So it's called the language, it's called NoSQL, not only SQL. Okay. So, for NoSQL, there should not be any columnar structure. For table, I already mentioned it. They are storing the data in key value pair. This manner. So, if we need to fetch anything from there, we can use NoSQL. But as of now, in the further courses, we will be only focusing on the SQL part. Because mainly for the data analytics, data engineering, for the data analytics part to, bring the data to organize the data. Specifically, SQL is the first priority. There is a quick example of the NoSQL database, how they can be stored over here. You can see. For NoSQL database, one more thing I just want to mention over here for hierarchical data. If we want to store any hierarchical information, just like you can see, first name, last name is alive, age, those can be represented in relational database as well. Just like those can be column. Those are the data for the first row. That is fine. Now starting from address onwards, you can see this can be column, then this can be sub columns. But this is a hierarchical structure in NoSQL, which is not possible in SQL database. So to maintain hierarchical database, it's very much easier for NoSQL to store the data. But over there, okay, let me show the thing in example. I'm just giving this thing. So what are the data? If I just try to convert this thing in SQL, first name, last name is alive, age, address. First name, last name is alive, age. Okay. So the data should be just like this. John Smith. This is the header, means columnar structure. I'm entering the data. True. 27. Now coming to the next column. If we just trying to convert this thing, we need to maintain in this way. We cannot maintain the hierarchical structure in relational database. We directly have to put in this manner. Street address. Okay. City. Or I can put in this manner. The first field, the parent field name is address. I can just maintain address underscore street address. Address underscore city. So I have to maintain, I have to break it up. I need to parse the JSON and bring those things in a column. So address, street address, this kind of stuff. City. state, postal code. So this kind of hierarchical structure, it's not easy to maintain in relational database. We need to break this thing and maintain this thing in a single, I mean, columnar structure if we just try to convert this thing over here. So that is why I just try to mention for the hierarchical structure, or if we just maintain this kind of hierarchy, then NoSQL is preferable. But similar kind of stuff we can definitely convert in SQL. It should be looking like in this manner. It's not maintaining the hierarchy over here. It's not just like this address. I'm just repeating over here. Then inside the address, I'm merging this cell. This kind of things will not be, you cannot find in relational database in hierarchical way of representing the columns over there. Okay. So just to bring the advantage, one of the advantage of NoSQL over here to maintain the hierarchical data. Okay, there is another thing, the data representation on top of charts and graphs. So you can see over here the tabular data structure is there, this one, and we try to convert the same thing in a particular charts. So the data should be also looking like in this manner. Okay. So it's called visualization representation of the data. So when our data is ready in data warehouse, then there should be some visualization engineer. They can be also, I mean, inside that data engineering part itself. So they can create those kind of charts and graphs on top of data so that business owner can take decision by checking those charts and graphs. Okay. Okay, there's a basic example with MS Excel. Let me check it. Give me 1 second. Data engineering courses. Yeah, I have an Excel sheet. Okay, I just want to mention some more thing. The visualization part. Okay, let me show you. I have the data in this manner. There is product. In the particular database, there is product column, price column, discount column, final price column. Okay, and I'm inserting 3 records. Suppose cap, whose price is 500, discount is 20 rupees or 20 USD. I mean, the particular currency you can choose your own way. The final price is this, board, pen drive, everything has their data. Now I try to convert the same thing in a chart. I'm just inserting the thing in a chart. Suppose this one. So for this representation of data, just look the data. We are just mentioning price over here, discount over here, and final price over here. So this is one kind of representation of the data by bar chart. And inside price, I'm representing the blue one as cap, the orange one is board, and this one is pen drive. But as per a business analyst, this chart is not very much helpful. I want to check and compare. I want to group this information based on product, not based on price, discount, and final price. Okay, the same thing I'm representing in a different way. Just see it. I'm just deleting it. I'm representing the same thing in a bar chart, but grouping by the product only. I can get it from here. Uh, Not this one. Okay, now see the data. Here it's also a bar chart. Now I'm grouping the thing on top of product and it is very much helpful. So based on the business requirement, the same kind of data I have represented in the bar chart in two different manner. But I need to concentrate what business wants to check. Whether the data should be grouped by product or whether it's grouped by this price, discount and all. So here I'm grouping it product. So a particular business analyst, they can easily check it. The blue should be the price. This is discount and I'm subtracting this part. Okay. So this blue minus this orange should be, this is the final one. So it's totally dependent on the business, how they want to check it. So we need to understand the same requirements and we need to represent the data in the following manner. I just try to convey this thing to say the difference between the same charts can be represented in different manner, which should be having different business logic. Different business representation too. Okay. So, any doubt till now from anyone? I think this is the last slide to be covered today. Uh, okay, nothing else for today. Tomorrow we'll be starting with the data normalization part, as well as we'll be focusing more on, primary key, foreign key once more time. And we'll be introducing the databases tomorrow. And the day after tomorrow, it's totally the technical stuffs, especially the SQL and their hands-on stuffs and all. We'll be covering one by one. From Monday onwards, we'll be starting totally the technical stuffs on SQL. So is it fine for everyone now? Can you please send the slides for reference? Yeah, you can definitely share it. I'll not be sharing the slides. I'll be sharing the particular recordings as of now. If it is fruitful for you, if it is not, then I can try to share it. Okay. The recording will be saved some location. You can definitely check it from there only. I'll be sharing this thing to the admin team of this Tetra course, and they will be storing it to some YouTube link, and they can provide it to you. Okay.
All right. Thank you so much.
Yeah. Thanks
Thank
everyone. Thank you. Bye bye. Let's connect tomorrow.
Yeah, thank you.
Bye. Thank you.
Thank you.